Company scenario: Marcus Okafor is preparing for Sprint 23 at Product Forge, a 2-week sprint starting Monday. The Flowboard development team for this sprint consists of 4 developers. One, Sophia, is on planned leave for all of week 1, 2 Q&A engineers, both available for the full sprint, and 1 designer, available for the full sprint. Over the past 4 sprints, the team's actual velocity has been Sprint 19, 34 points, Sprint 20, 28 points, Sprint 21, 33 points, Sprint 22, 31 points, giving an average of 31.5 points. Marcus has a list of 12 candidate stories for Sprint 23, but this workshop focuses on the 6 most significant ones. Before the planning session can begin, CTO Ravi Menon has sent Marcus a message requesting a stretch goal of an additional 10 story points beyond the team's normal capacity target. He wants to demonstrate to investors that the team is accelerating. Marcus needs to plan Sprint 23 realistically, use data to push back on the stretch goal request, and communicate the plan credibly to Jessica Park. Workshop, you will take on Marcus's role and complete 2 exercises. First, calculating true sprint capacity and producing AI-assisted estimates for 6 candidate stories. Second, building the Sprint 23 plan and preparing a data-backed response to Ravi's stretch goal challenge. Learning objectives. 1. Calculate Sprint 23's true available capacity using historical velocity, the 80% capacity rule, and leave adjustments, producing a specific justified capacity target rather than a theoretical maximum. 2. Apply AI-assisted estimation techniques to 6 flowboard stories using historical reference data and story complexity signals to produce point estimates with confidence flags. 3. Flag high uncertainty stories and articulate the specific complexity driver that makes them harder to estimate reliably. 4. Build a realistic Sprint 23 plan that fits within the calculated capacity. Select stories based on WSJF priority and maps key dependencies between selected stories. 5. Compose a concise, data-backed response to Ravi Menon's stretch goal request that demonstrates leadership capability using sprint data to defend a principal decision without being dismissive of the CTO's strategic intent. Materials needed. This is a paper-based exercise. You will need a blank A4 sheet or notepad and a pen or pencil. No computer, software, or internet access is required. Exercise overview. Exercise 1, 25 minutes. Capacity calculation and story estimation. You will calculate Sprint 23's true available capacity. Draw an estimation table for 6 provided stories. Apply AI-assisted estimation logic to produce point estimates. Flag high uncertainty stories, and write a 1-sentence complexity driver summary for each story. Exercise 2, 20 minutes, sprint planning and stretch goal challenge. You will select stories to fill sprint 23 to 80% capacity. Build a dependency map. The sprint goal in outcome format. Draft a 3-bullet sprint 23 plan summary for Jessica Park and compose a data-backed response to Ravi Menon's stretch goal request. Both exercises use the same 6 flowboard stories. You will build your estimation work in exercise 1 and use it as the input for your planning decisions in exercise 2. Success criteria. You will know you have succeeded when 1. Your capacity calculation produces a specific target in story points that is justified with reference to historical velocity, the 80% rule, and leave impact. 2. All 6 stories have point estimates with at least 1 confidence flag and 1 complexity driver sentence. 3. Your sprint plan selects stories whose total estimated points fall within your calculated capacity. 4. Your sprint goal is written in outcome format describing the user or business result, not as a feature list. And 5. Your response to Ravi Menon references specific sprint data, acknowledges his strategic intent, and proposes an alternative that addresses his goal without destabilizing the sprint plan. Step 1. Calculate Sprint 23's available capacity. Start by writing the 4 recent sprint velocities. Sprint 19 equal to 34 PTs. Sprint 20 equal to 28 PTs. Sprint 21 equal to 33 PTs. Sprint 22 equal to 31 PTs. Calculate the average: 34 plus 28 plus 33 plus 31. 4 equal to 31.5 points. Now apply the leave adjustment. Sophia is one of 4 developers and is absent for all of week 1. That is 50% of her sprint contribution lost. Assume each developer contributes equally to velocity. So Sophia's absence reduces capacity by approximately 25% of her normal sprint contribution. With 4 developers contributing roughly equally, Sophia's full sprint contribution is approximately 25% of developer-driven points. But her absence impact as 12.5% of total sprint velocity, half her sprint, at 25%, share equal to 12.5%. Subtract this from your baseline, 31.5 times 0.875 equal approximately 27.6 points. Round to 28 points as your leave adjusted velocity. Now apply the 80% capacity rule. 28 times 0.80 equal to 22.4 points. Round to 22 points as your sprint 23% planning target. Write this number prominently on your paper. Sprint 23% capacity target, 22 story points. This is the number you will plan to. Step 2. Draw an estimation table with 4 columns: story name, AI assisted estimate, story points, confidence level, high, medium, low, and key complexity driver, 1 phrase. Leave 6 rows for the 6 stories. Now apply AI-assisted estimation logic to each story using the reference data below. For each story, identify the closest historical analog and use it to anchor your estimate. One burned down chart on sprint dashboard, similar to 3 past stories, 3 ACs, no external APIs. Historical analogs are display sprint progress bar, 2 PTs, show team capacity widget, 3 PTs, dashboard date filter, 3 PTs. 2 email notifications for blocked items involves email service integration, 5 ACs. Historical analogs are email digest feature, 5 PTs, push notification system, 8 PTs first integration, high variance. The email service has been integrated once before. Estimate 5 points. Story S3 team velocity report page. New page connects to 2 data sources, 6 ACs. Historical analogs are sprint summary page, 8 PTs, analytics dashboard V, 1, 13 PTs new page with multiple data sources. 8 points. Story S 4, allow PMS to edit sprint goal mid-sprint, role permissions involved, 4 ACs. Historical analogs are edit sprint name, 3 PTs no permissions, role-based export control, 5 PTs with permissions check. Estimate 5 points. Story S 5 fix duplicate notification bug, bug fix reproduction confirmed, 2 ACs. Historical analogs are fix stale status patch, 2 PTs, fix missing avatar bug, 1 PT. Estimate 2 points. Story S 6 import stories from CSV file, File parsing, validation logic, 7 ACs, new integration. Historical analogs are export to CSV. 3 PTs simpler, output only, bulk story edit, 8 PTs. CSV import is a new integration type for this team. Estimate 13 points. Record your estimates in the table. Step 3. Assign a confidence level to each story's estimate. Use these criteria. High confidence equal to stories very similar to 2 or more completed stories with consistent past estimates, no new integrations, no new technical territory, and clear acceptance criteria. Medium confidence equal to story resembles past work in general but has 1 or 2 factors that introduce uncertainty. First, use of an existing integration in a new context, ACS that could expand, a new permission layer. Low confidence equal to story requires a new integration, involves new technical territory, has ACS that are broadly worded and could expand significantly, or lacks a close historical analog. Apply these criteria to each of the 6 stories and record high, medium, or low in the confidence level column. Write your rationale in one brief note per story next to your confidence rating. At least 2 of the 6 stories should be flagged as low or medium. If you have rated all 6 as high, reconsider your criteria. Step 4. Add up the total estimated story points across all 6 stories. Compare the total to your sprint 23% capacity target of 22 points. The following calculation on your paper. Total estimated points equal to your sum. Sprint 23% capacity target equal to 22 points. Gap equal to difference. If total estimated points exceed the capacity target, this means you cannot plan all 6 stories into sprint 23. You will need to make selection decisions in exercise 2. If the total is below the capacity target, note the remaining buffer. This will inform how many additional candidate stories could be pulled in from the backlog. Calculate what percentage of your capacity target the total estimates represent. Total estimates, 22 times 100. Note whether this is above, below, or approximately equal to 100% of the 22-point target. Step 5. For each of the 6 stories, write one sentence in the key complexity driver column that identifies the single most important source of complexity or uncertainty for that story. Your sentence should be specific, not "this story is complex," but rather the key complexity driver is the email service integration, which has been done once before, but not in this notification context. Use the estimation reference data from step 2 to identify what makes each story more or less certain. Good complexity driver sentences identify a specific technical, organizational, or requirements level factor, not a generic statement. These sentences will be useful in exercise 2 when you decide which stories to include in the sprint and which to defer. Key takeaway: AI assisted estimation is not about replacing developer judgment. It is about grounding estimates in historical reality before the conversation begins. When teams start with reference data from comparable past stories, the anchoring bias works in their favor rather than against them. The result is not perfect estimates. No estimates are perfect, but estimates with known uncertainty, bounded by a historical reference class, that produce more reliable sprint plans than unaided optimism. Step 1. Select the stories for sprint 23 using your capacity target of 22 points and the estimates from exercise 1. Your selection must meet the following constraints. A. Total estimated points must not exceed 22 points. B. You must prioritize stories by WSJF logic. Higher value, lower effort stories with urgency signals should be selected before lower value, higher effort stories. And C. Any story with a low confidence rating should be given a planning note, a brief sentence about what would need to happen for this story to be delivered within its estimate. List your selected stories with their point values. Calculate the total and confirm it is at or below 22 points. Note which stories you are deferring to Sprint 24 and write a one-sentence rationale for each deferral. A strong rationale references either the story's size relative to available capacity, its confidence level, or its dependency status, not just we ran out of space. Ravi Menon has requested a stretch goal of an additional 10 story points. Before you respond, quantify the risk of accepting this request. On your paper, write the following calculations. First, the proposed total, your selected stories at or below 22 points, plus 10 stretch goal points equal to total. Second, what percentage of leave adjusted velocity this represents, proposed total 28 times 100. Third, the historical context across the last 4 sprints, how often did the team exceed their actual velocity? Answer. Sprint 19 was highest at 34 points. That is the only sprint where 32 plus points was delivered. Fourth, write the probability statement. Based on the last 4 sprints, the team has delivered 32 plus points once out of 4 sprints, a 25% success rate. Calculate the consequence if the stretch goal is accepted and the team delivers at their average of 31.5 points. How many points of committed work are at risk of not being delivered? Show all of this working on your paper. These are the numbers you will use in your response to Ravi in step 4. Step 3. Draw a dependency map for your selected sprint 23 stories. Place each selected story's name in a circle on your paper. Then draw arrows between any stories that have a dependency relationship. Use the following dependency clues from the stories. S1, burn down chart, may depend on velocity data being available. Check whether S3, team velocity report, needs to be built first, or whether the data is already available from another source. S2, email notifications for blocked items, depends on the email service integration node, whether any other planned story uses the same service, creating a shared dependency that should be sequenced. S5, fix duplicate notification bug. Consider whether fixing the notification bug before building new notification features, S2, would reduce rework risk. Label each arrow with the dependency type, sequential, resource, or quality order, where completing one story first improves the quality or reduces the rework risk of another. Identify the critical path, which story should be started first to protect the most downstream work. 4. Write your response to Ravi Menon's stretch goal request. Your response must be written as a professional message, not as bullet points or a table, but as a short paragraph of 5 to 7 sentences that you would actually send. The message must include A. An acknowledgement of Ravi's strategic intent. You understand why demonstrating team acceleration matters for investors. B. The specific risk data from step 2. Include the velocity numbers, the 25% historical success rate, and the points at risk figure. C. The consequence of overcommitment for the stories that are in the plan if the team overcommits and delivers at average velocity. Which committed stories are at risk of not being delivered? And what is the stakeholder impact of that outcome? D. An alternative proposal, for example, designating the one additional story from your deferred list as a formal stretch goal that the team will pull in if they complete their committed scope early, making it visible and celebrated as a stretch without making it a commitment. The goal is to be honest about risk, respectful of Ravi's intent, and constructive with a specific alternative. Step 5. Write 2 deliverables. First, write the Sprint 23 goal in outcome format One sentence that describes the user or business result the team is working toward, not a feature list. Good sprint goal answers: at the end of this sprint, users or the business will be able to do something valuable that they could not do before. Examples of poor sprint goals: complete S1, S2, and S5. Examples of good sprint goals: team leads can access real-time sprint performance data and receive timely notifications about blocked work. Bullet. Second, write a 3-bullet sprint 23 plan summary for Jessica Park. Bullet 1, sprint goal and its connection to Q2 priorities. Bullet 2, capacity rationale: why the team is planning to 22 points rather than a higher number, and what that means for delivery confidence. Bullet 3, key risk or dependency to watch during the sprint and how it is being managed. Write this summary in plain business language. Jessica is data-driven but not deeply technical. Key takeaway: a sprint plan is a commitment, not a wish list. The difference between a plan the team owns and a plan the team endures is whether the commitment level is realistic, whether the goal is motivating, and whether the risks are visible before the sprint starts rather than discovered during it. Fact: pushback using velocity history, confidence intervals, and capacity calculations to defend a realistic plan against external pressure is not a sign of low ambition. It is a sign of professional product leadership. What you practiced: in exercise 1, you calculated sprint 23's true available capacity using 4 sprints of historical velocity data, a leave adjustment for one developer absent in week 1, and the 80% capacity rule arriving at a specific justified planning target of 22 story points. Then applied AI-assisted estimation logic to 6 flowboard stories, anchoring each estimate in historical reference data, assigning confidence levels based on story characteristics, and writing one-sentence complexity driver summaries that captured the specific uncertainty in each estimate. In exercise 2, you selected stories to fill the sprint within capacity, quantified the risk of Ravi Menon's stretch goal request using historical data, mapped dependencies between selected stories to identify the critical path, wrote a sprint goal in outcome format, drafted a 3-bullet executive summary for Jessica Park, and composed a data-backed professional response to the stretch goal challenge. Together, these exercises represent the complete sprint planning workflow of a high-performing product owner. Historical velocity as the planning anchor: the most reliable input to sprint planning is not team optimism, not stakeholder ambition, and not theoretical capacity, at the actual delivery history of the specific team on the specific product in recent sprints. When Marcus calculates a 22-point capacity target from 4 sprints of actual velocity data, adjusted for leave and the 80% rule, he is using the most accurate predictor available. Number may feel conservative relative to what stakeholders want, but it is the number that produces sprint plans the team can actually deliver. Consistently delivering committed scope builds the trust and credibility that allows product owners to negotiate confidently about scope, priority, and roadmap commitments. Key concept: to capacity does not equal velocity. One of the most persistent planning errors is confusing the team's historical velocity with the team's available capacity in a specific sprint. Velocity is what the team has delivered on average. Capacity is what the team can deliver in this specific sprint, accounting for absences, dependencies, and risk adjustments. In sprint 23, the team's average velocity is 31.5 points, but after Sophia's leave adjustment and the 80% capacity rule, the planning target is 22 points. Planning to 31.5 points as if the team were at full strength would be a category error. AI helps POS make this distinction automatically and consistently so that capacity calculations reflect the real conditions of each sprint rather than an idealized long run average. Key concept 3, data back pushback as leadership skill. When Marcus responds to Ravi Menon's stretch goal request by presenting 4 sprints of velocity data, a 25% historical success rate for delivering above average, and a specific calculation of how many committed points would be at risk, he is exercising a form of leadership that is grounded in evidence rather than opinion. This approach is more effective than simply saying no because it demonstrates that the decision is not arbitrary. It opens a productive conversation about risk tolerance, and it proposes a constructive alternative, a formal stretch goal that honors Ravi's strategic intent without making an unrealistic commitment. Product owners who master data backed pushback earn more trust, not less, from technical and executive stakeholders alike. Applying this to your organization. When you return to your own sprint planning cycle, start by calculating your team's average velocity from the last 4 sprints and setting your next sprint capacity target using the 80% rule after leave adjustments. Compare this target to the story points your team typically commits to. If there is a consistent gap, you have identified the primary driver of your sprint completion rate. Before the next planning session, prepare a simple estimation reference table. List 5 to 10 recently completed stories with their actual delivered points. Use this table as an anchor in your next sizing conversation. Present it at the start of the estimation session and ask the team to score new stories relative to the reference items. For the stretch goal challenge, if your organization has a culture of stretch commitments, prepare a one-page velocity fact sheet that you can share with leadership before each planning cycle, showing actual velocity data and its variance. Making the data visible proactively is more effective than surfacing it reactively when a challenge arises.